Yeah, very good morning, dear. Am I audible to everyone? Respond quickly.
Yes, sir,
Yeah,
you're audible.
yeah, very good, dear. So we'll discuss today addition reaction, substitution reaction, and what is the difference between addition and substitution reaction, and then what is ester and esterification and sulfonification, and how the ester forms. Okay. So today we'll discuss those things. Now look at here, addition reaction and substitution reaction. First, take any substance of carbon, first of all. Reason for addition and substitution reaction, if you see saturated hydrocarbons and what are the another types of hydrocarbons here?
Unsaturated.
Unsaturated hydrocarbons, is it right? Saturated hydrocarbons is nothing but what type of hydrocarbons those are? Like alkanes or alkenes or alkynes?
Sir, alkanes, single bond.
Alkenes and alkyne.
Alkenes and alkynes comes under unsaturated hydrocarbons, is it right? Whereas alkanes comes under saturated hydrocarbons. Saturated hydrocarbons are nothing but which are having single bond. Yeah, very good. Which are having single bond, is it right? And unsaturated hydrocarbons is nothing but the which are having two or more bonds, is it right? So if you see here saturated hydrocarbons, so here we are doing addition and substitution reaction. So addition reaction is for which type of hydrocarbons and substitution reaction is for which type of hydrocarbons. Okay, very, very important, Nana. Look at here, addition reaction and substitution. Substitution is nothing but what? Replacing with other one. Is it right? Substitution. The word substitution says for if you are having one element, in place of this element, you are replacing this element with the other element. Is it right? That is nothing but what we call substitution. Addition is nothing but what? Adding. Adding, is it right? So here two types of reactions are there. Now look at here, saturated hydrocarbons. What is the name of this structure?
Ethane.
Ethane. Why we will call it as ethane? How many carbons are there? Two carbons. It
Two
means
carbon.
ethane. All single bonds are there. So ethane. Is it right? Now, if you react with chlorine gas means how many chlorines will be present in that? Chlorine gas means two chlorines. Is it right? So we'll write it as chlorine bond chlorine. Is it right? Two chlorines. Now, out of these two chlorines, one chlorine will replace this hydrogen. Is it right? Then where this hydrogen goes? It will react with another chlorine. Is it right? It means we are replacing or we are substituting or what we are doing? What we are we adding here? Or we are substituting?
Substituting.
We are substituting. In place of hydrogen, we are substituting chlorine. Is it right? And where this hydrogen is going?
To another, reacting with another chlorine.
Is it right? Now, if you simply see here, we are substituting here carbon and hydrogen is there. Now, chlorine is also there. This hydrogen is reacting with one chlorine. Okay, it means it is substituted now here. It is replaced here. Okay, now this chlorine is reacted with carbon, and then this chlorine will react with
Hydrogen.
and it forms HCl. Is it right? Now, can you guess what is the name of this structure? Initially, it was ethane. Is it right? Ethane. Now it becomes chloroethane. Is it right? Chloroethane. Then how many chlorines are present here?
Yes, sir.
Only one. Is it
Yes,
right?
sir.
In this structure. Only one chlorine. So can we say it as a monochloro?
Sir.
Monochloroethane. And this is hydrochloric acid. What type of reaction it is? Addition or substitution?
Substitution.
You can say here the monochloroethane is formed, and here this is a type, substitution reaction. So saturated hydrocarbons are addition reaction or substitution reaction?
Substitution reaction.
So for saturated hydrocarbons, always substitution reaction takes place. Okay, we are not adding anything, we are substituting. Why? Because all are single bond only. If you are having any double bond or triple bond, then to remove one bond from that, then we will add some other elements. Okay, like some are other elements of any family members. Now, if you see here, for this unsaturated hydrocarbons, any type of reactions, if takes place, it means this unsaturated hydrocarbons converts into or changes to saturated hydrocarbons. Is it right? We are changing unsaturated hydrocarbons to
Saturated hydrocarbon.
saturated saturated hydrocarbons. Is it right? What are saturated hydrocarbons? Which are having single bond.
Single bond.
Single bond. It means we are changing this double bond into single bond. Is it right? Now, if you see here, this double bond structure, what is the name of this structure?
Ethene.
Ethene. Is it
Yeah.
right? Two carbons are there and one double bond is there. So it is ethene. So now I am changing this one into carbon and carbon with single bond. Initially there were 4 hydrogens. So simply write as 4 hydrogens. Now that double bond removed and that bond has shared 2 carbons individually and then shared 2 hydrogen. Okay. How many hydrogens are added here?
2.
Two,
It
sir.
means it is reacting with which gas?
Hydrogen gas.
Hydrogen gas. It means we are adding or we are substituting here.
Adding.
Adding,
So
sir.
what type of reaction it is?
Addition reaction.
Addition reaction. Is it right? So in the presence of in addition reaction, always remember unsaturated hydrocarbons changes to
Saturated hydrocarbons.
in the presence of catalyst. Okay. So here we'll see the reaction. Catalyst means nickel or K2Cr2. Is it right? We have discussed in that while discussing this chapter. Now you can see here ethene. Ethene is present here. Now we are reacting with chlorine. Is it right? For example, then will it react? 2 chlorines are presented here. Now, instead of hydrogen, we can react with any halogen member. Is it right? Halogens are chlorine, bromine, iodine, etc. Why? Why? Because they are also having what type of bond? Single or double bond?
Single.
Chlorine is also having single bond. Bromine is also having single bond. Iodine is also having single bond. And what about hydrogen? Hydrogen is also having
Single bond.
single bond. So we can replace any element which is having single bond here. Okay. Now chlorine has replaced by this double bond actually now. Okay. It means we have added chlorine gas, 2 chlorines. Dichloro. Is it right? 2 chlorine means
Yes, sir.
dichloroethane now. It is changed into anes. Is it double bond or single bond structure now?
Single bond.
Single bond.
Single bond structure. So can we say it is a saturated now?
Yes, sir.
A saturated hydrocarbon. Now can you say here for this? Triple bond structure is there. So what is the name of this structure first of all?
Fine.
Ethine. Very good.
Ethyne.
Ethine. So change into a saturated hydrocarbon first. So it is not possible to directly change into saturated. First of all, how many bonds are present in this structure? How many bonds are there between carbon and carbon?
Triple bond.
Triple bond is there. Then change into double bond first. Okay. Change into double bond and then we'll change into single bond. So that is the process. It is not possible to directly change from triple bond to a single bond to become a saturated hydrocarbon. You can see here ethine, which is having triple bond structure between carbon and carbon. So we are adding what here?
Chlorine.
Chlorine. So why only chlorine, sir? Why not other elements? You can, okay, which are having monoatomic, means mono bond. Mono means what? Which type of bond?
Single bond.
Single bond. Is it
Single,
right?
sir.
Simply, I have replaced one bond with how many chlorines? How many chlorines?
Two.
That to remove one bond, we need two single valency elements. Here, chlorine is having single valency, so two chlorines are required. Okay, attach with two chlorines here. Then, if you see the structure, what is the name of this structure? Try to answer the name of the structure.
Ethene.
Right,
Ethane, sir.
ethene only, but what is the name of the complete structure?
Dichloroethene.
Excellent answer, dear. Dichloroethene. Is it right? So it is dichloroethene. Now, our process is converting of unsaturated to saturated. Is it right? Now you can see here, saturated hydrocarbons undergoes which type of reaction?
Substitution reaction.
Substitution reaction. Very good. They contain single bonds which are stable. Okay. So always remember, saturated hydrocarbons undergoes always substitution reaction. And look at here, unsaturated hydrocarbons undergoes addition reaction. They contain double and triple bonds. C double bond and C triple bond. Here are not hydrogen, carbon and carbon only. Okay, which are weaker and easier to break. Okay, if they are having double bond and triple bond, we can break them easily by reacting with any other halogen member. Now, if you see addition reaction, unsaturated hydrocarbons changes to in addition reaction.
Saturated hydrocarbons.
Yeah,
Hydrocarbon.
excellent, dear. Unsaturated hydrocarbons changes to saturated hydrocarbons in the presence of catalyst and by
Yes, sir.
adding hydrogen. Is it right? Why only hydrogen, sir? Why not any other element which are having halogen family member like single bond? First, we will react with hydrogen to convert into saturated. Then we'll replace this hydrogen with any other element. Is it right? Now you can see here what type of structure it is: saturated hydrocarbon or unsaturated hydrocarbon?
Unsaturated.
Unsaturated, sir.
Unsaturated hydrocarbon.
Triple
Sir, there
bond.
are 3 bonds, no, sir. C.
Yeah, three bonds are there. So it comes under alkanes or alkynes.
Alkynes.
All kinds.
Alkynes. That's why eth ine. Is it right? Two carbons are there. Eth and triple bond is there. That's why it is ine. Eth ine. In the presence of nickel catalyst, and we are adding what?
Hydrogen.
Hydrogen, sir.
Is it right? Addition reaction. Is it right? We are adding hydrogen here. Addition reaction. Now, then what is the name of the structure?
Ethene.
Ethane.
Ethene. Still, it is a saturated or unsaturated?
Unsaturated.
Unsaturated, sir.
So again, if you react, is it right? Again, if you react, what will get here? Saturated. So in the presence of what? Nickel catalyst. So with what element? Which element we have to react again?
Hydrogen.
H2, sir.
Hydrogen. H2. Why? Because here double bond is there. If you react a hydrogen gas with this double bond, means with this ethene in the presence of nickel catalyst. Is it right? Again, now can you guess what is the name of the structure which we'll get here?
Ethane.
Ethane, sir.
How many hydrogens will be there in that ethane? How many hydrogens will be present?
6.
6, sir.
If you observe here, initially there were how many hydrogens are there?
2.
2.
Now, after reacting with in the presence of nickel catalyst and with hydrogen gas, so how many hydrogens were added in this? 2 hydrogens are added and total are
4.
4.
now still it is unsaturated. Okay, but now again this unsaturated hydrocarbon again is added by which element? Hydrogen gas here in the presence of
Nickel catalyst.
nickel
Nickel
catalyst. Now it is converted into from unsaturated to
Saturated.
Saturated.
saturated. Now how many hydrogens are there?
6.
6 are
6.
there. Is it right? Now this is the process of changing unsaturated hydrocarbons into saturated
Saturated.
hydrocarbons. So what type of reaction it is? Addition or substitution?
Addition
Addition.
reaction.
Addition reaction.
So then can you convert saturated hydrocarbons to unsaturated?
No. We have to remove them. Is it right? We have to remove
Yes,
the
sir.
hydrogens. Now that reaction not comes under addition reaction. Is it right?
Yes.
Now, in this addition, after doing addition reaction, if you replace this hydrogen with any halogen member like chlorine, bromine, so what type of reaction that is?
Substitution reaction.
That comes under
Substitution.
substitution reaction. Is it right? Substitution reaction. Now, substitution reaction takes place only for saturated or unsaturated hydrogen.
Saturated hydro.
Only for saturated hydrocarbons. Is it clear? What is the difference between substitution and addition reaction? The addition reaction of hydrogen to an unsaturated hydrocarbon to obtain a saturated hydrocarbons is called hydrogenation. Can you define what is hydrogenation?
The addition of hydrogen
The addition of hydrogen to an
to an unsaturated
Very
hydrocarbon.
simple. Addition of hydrogen to a unsaturated hydrocarbon to convert into saturated. Then that process is known as that process of what we call hydrocarbons is known as hydrogenation. Adding of hydrogen gas to unsaturated to change into saturated is known as hydrogenation. Is it clear? The process of hydrogenation has an important industrial application. It is used to prepare vegetable ghee from a vegetable oil. Okay, like you can see here or structures. So vegetable oil, unsaturated fat liquid state. In the presence of catalyst and we are adding hydrogen here, it is changing into vegetable oil ghee. Okay, saturated fat solid state. Okay, now we'll discuss about substitution reaction. Saturated hydrocarbons undergo substitution reaction in the presence of
Light.
sunlight. Okay, so CH4, what is the name of CH4?
Methane.
Methane.
methane,
Right, and we are reacting with
chlorine,
chlorine. Is it right? Now methane reacting with chlorine gas. Now here we are substituting hydrogen with
Chlorine.
chlorine,
means initially methane is having how many hydrogens here?
4.
4. Now we are reacting with chlorine here. It means 2 chlorines are there. So this chlorine replacing this hydrogen and it gives CCl. Another chlorine is replacing this hydrogen. Any 2 hydrogens, okay? Any 2 hydrogens. Now here one more chlorine. Now remaining are hydrogens. Is it right? And it replace and it gives H2. Now, what type of reaction it is?
Substitution.
Substitution reaction. So may I know the name of this structure?
Dichloro.
dichloro,
Dichloro
Methane.
methane. Very good answer. This is single bond structure, methane, and 2 chlorines are present, dichloro. Is it right? So this is what we call substitution reaction. CH3Cl or CH2Cl2 also you will get. Okay, dichloro means single chloro is this one, methyl chloride plus HCl. Okay. Now you can see here the replacement of hydrogen atom with a halogen in an organic compound is called halogenation. This is also one type of definition for halogenation. Okay.
yes,
Reaction with the halogens. So CH4 methane is reacting with chlorine to give rise methyl chloride or dimethyl chloride also will get. Okay. Methyl
yes, sir.
chloride plus hydrochloric acid. So here methyl chloride if reacts with another chlorine and again it gives dimethyl chloride. Is it right? 2 chlorines are reacting and again what will get here? HCl, hydrochloric acid. This is also very easy, Nana, but very important as well. Okay, hydrogen atoms are replacing with 2 halogen members. So if you do further reaction, it will changes to
Substitution.
trichloromethane. Is it right?
Trichlor.
HCl. Again, if you want to do substitution reaction with this hydrogen, what type of reaction you'll get? All 4 chloros. Is it right?
Sir.
tetrachloromethane. Okay. You can say it is also known as carbon tetrachloride. Okay, HCl will get again. Now, importance of carbon compounds, ethanol, ethanoic acid. What is ethanol? It is a liquid at room temperature, is it right? Commonly called alcohol. Eth and all. Eth means how many carbons?
2.
Two carbons. And means saturated or unsaturated?
Unsaturated.
And
Saturated.
Saturated.
so all single bonds, is it right?
Yes, sir.
And what is added here? Alcohol, OL means, is it right?
Sir.
Simply we'll add OH. C2, how many hydrogens are? 1, 2, 3, 4, 5. H5, what is this? OH. So what is the name of this structure?
Ethanol.
Ethanol. It and all. Is it right? Ethanol.
Sir,
Basically, where we'll use this? Yeah.
sir, we can write CH3, CH2,
Why
OH,
CH3? Yeah, okay, you are
CH4.
saying, yeah. Yeah, CH3, CH2, OH. That is also same.
Yes,
See, CH3, is it right?
yes, sir.
CH2, OH. Is it right?
Sir.
Yes,
Both are
sir.
correct only. Both are correct. Now, active ingredient of all alcoholic drinks. So, which alcohol is present in the drinks means? Simply you can say, okay, alcoholic drink, which is this is the best ingredient for this. So, because it is a good solvent, it is also used in medicines such as, what is this? Tincture, iodine, and then cow syrups and many tonics. Okay. So soluble in water in all proportions. At any proportion, if you add into the water, it will soluble. Okay. Now look at here. You know what is ethanol? What is the chemical formula of ethanol?
C2H5OH.
C2H5OH.
OH.
Yeah, very good. So reaction with sodium. So whenever ethanol is reacting with sodium, just look at here. Na plus CH3 CH2OH or C2H5OH. Can you guess what we'll get here? Sodium plus ethanol. Guess, Nana. What reaction we'll get here? Fast, without wasting time. Please respond quickly.
Sodium ethoxide plus hydrogen.
Sodium ethoxide plus hydrogen, is it right? CH3 CH2ONA. Here you can see here hydrogen is replacing with Na. Is it right? So here CH3 CH2ONA. What is the name of CH3 CH2ONA? Fast. Sodium ethoxide. Is it right?
Yes, sir.
Eth means two carbons are present. Oxide. Okay. Oxygen is present. So ethoxide. Then which element is there? Sodium.
Sodium.
So sodium ethoxide. Is it right? Then simply if you balance with 2, then to liberate a hydrogen gas, we have to balance here. Okay, 2, then again 2 NAs. So now it is balanced almost. 2 NAs are replaced with 2 hydrogens to release hydrogen gas and to form sodium ethoxide. So reaction to give unsaturated hydrocarbons. Dehydration of ethanol. What is the meaning of dehydration? Dehydration means what? Removing
Sir,
of removing of
Water.
Hydrogen.
hydrogen.
hydrogen. Is it right? Removing of hydrogen is nothing but dehydration. From what?
Ethanol.
So
Ethanol.
if you dehydrate ethanol, what you will get? Okay. So if you dehydrate, then you will get unsaturated hydrocarbon. Look at here. CH3, CH2OH. This is what? What is the name of this structure? Carbon compound. Ethanol. If you dehydrate it, dehydrating means what we have to do here? Heating process. Is it right? Hot concentration. H2SO4. H2SO4 is acid or base?
Acid, base,
H2SO4, sulfuric acid. Is it right?
sulfuric acid.
Now it became CH2, means C2H4. Is it right? C2H4. What is the name of this
Yes, sir.
structure? C2H4?
Ethene.
Ethane.
Ene. Is it right?
Yes, sir.
Ene. Why? Because double bond is present. And what is formed here? Water. Is it right? Very, very important. No oxidation reaction. Carbon compounds can be easily oxidized on combustion. In addition to this complete oxidation, we have reaction in which alcohols are converted into carboxylic acids. Okay. So it means by doing this oxidation reaction, it will convert into what? See, we are having
acid.
alcohol. What is the name of this alcohol?
Ethanol.
Ethanol.
So if you do oxidation reaction, it converts into carboxylic acid. Okay. So that is actually what this statement says. Converting of alcohol into carboxylic acid. Is it clear? Simply in the presence of catalyst, what is this? Alkaline KMnO4 plus heat energy, potassium permanganate, or acidified K2Cr2O7 plus heat energy gives rise CH3COOH. Okay, what is the name of this CH3COOH?
Ethanoic acid.
So ethanoic, carboxylic. What we'll call carboxylic means COOH. Is it right? From functional grouping names, if only double bond O present means what we call?
Aldehyde.
Ketone. Is it right? Ketone is present. Then CHO present means? Is it right? Is it aldehyde? And COOH present means carboxylic. Is it right?
Yes, sir.
Carboxylic acid. So when we'll call it as oic acid? Is it oic? Properties of ethanoic acid, commonly called as acetic acid, CH3COOH is also known as ethanoic acid, belongs to a group of acids called carboxylic acid. 5 to 8% of solutions of acetic acid in water is called vinegar. Can you define what is vinegar? I think this is second time I am reminding this.
So the substance which is used to clean the well.
No. Vinegar will use in fast food centers. Is it right?
Yes, sir. Even in cleaning also
So,
they will use no, sir. Means like
yeah.
flesh killing
Now look at
cleaning they
here.
will use.
Yeah, very good. Yeah. Acetic acid. How much percentage of acetic acid has to present in the water so that we call it as a vinegar?
5 to 8%.
5 to 8% of acetic acid is present in the water. That is nothing but vinegar. It is remaining all means 80, around 90 to 95 the percentage of water and 5 to 8% of vinegar. This acetic acid. Then we call it as it is a vinegar. Used widely as a preservative in pickles. Its melting point is 290 kelvins. 290 Kelvin means how many degrees? 290 Kelvin converts into degrees means 290 minus 273. What is the difference here? 23, yeah? 23 degrees.
27.
No. 290 minus 273. 27, huh? Very good. Okay. 27 degrees Celsius. No, not 27 dear, 17. Okay. 17 degree Celsius is the melting point of what we call this vinegar. Is it right? What is this? Frisian acetic acid is called glacial acetic acid. Okay. Reaction of ethanoic acid. Esterification. May I know what is esterification reaction?
Acid plus alcohol.
Acid plus alcohol. Take
Plus
ethanol.
alcohol.
Take ethanol plus sulfuric acid. What you will get? So what define ester? When acid reacts with alcohol, gives ester. Is it right? So you can see here CH3COH. What is the name of this structure?
Ethanoic acid.
Is it acid or not?
Yes, sir.
It is ethanoic acid, so
Yeah, very good.
CH3COOH.
Ethanoic acid. Is it right? CH3COH, ethanoic acid. And CH3CH2OH is?
Ethanol.
Ethanol.
What is the?
Ethanol.
Yeah, ethanol.
An alcohol, sir.
Ethanol. Ethanol. Ethanol, and it is ethanoic acid.
Yes, sir.
Ethanoic acid. And this acid is reacting with
Alcohol.
alcohol. So when
Alcohol.
acid reacts with alcohol, it gives.
Ester.
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 Can you define what is ester?
Acid reacts with alcohol, it gives rise to ester.
It gives rise ester. Okay. So may I know the structure of ester? CH3, COO, CH2, CH3. Is it right? So CH3, COO, CH2, CH3. Now CH2 is there. You can see here CH, H, H, C, O, C, C. How many hydrogens are there here with this carbon? 2. And for this carbon, 3. And here for this oxygen, 2 bonds are fulfilled. For this carbon, still how many valencies are there? 2
Two.
bonds are free. Then attach with ketone. Okay, ketone plus oxygen, COO. CH3, COO, CH2, CH3. What is the name of this structure?
Ester.
Ester.
Remember always.
Ester.
Define what is ester. Esterification reaction, when ethanoic acid reacts with ethanol, gives rise ester. And don't forget to write this equation. Is it clear? Very, very important equation, dear. Keep it in mind. Formation of ester. How it forms? So Bunsen burner is a tripod stand we used to call, and this is wire gauge, and this is what we call water here, and beaker, test tube containing reaction mixture. Which reaction mixture? Ethanoic acid and ethanol. So we are doing this reaction in the presence of acid here, and burning. Burning means heat energy. Saponification. Do you know what is saponification?
No, sir.
A reaction with carbonate and hydrogen carbonate. Give an example for carbonate.
Calcium carbonate.
Calcium carbonate, CaCO3. Any other examples? Calcium carbonate and sodium carbonate is Na2CO.
CO.
Then hydrogen carbonate means sodium hydrogen carbonate, we can say, is it right? NaHCO3. So take these 2 examples. This also will consider, but is already solid in state here. So calcium carbonate. You can take any one, but we are taking here sodium carbonates. Okay. We'll see the reaction here. Reaction with sodium carbonate. What is the name of this? CH3COH is?
Ethanoic acid.
Ethanoic acid.
It means carbonate reacting with acid.
Ethanoic acid.
Acid plus carbonate.
Carbonate.
And previously, To form ester, acid plus alcohol.
Alcohol.
Okay, acid plus alcohol is different, acid plus and carbonate is different. Ethanoic acid plus sodium carbonate gives rise in the presence of base solution. And ethanoic acid and alcohol in the presence of acid solution. Is it right? Previous equation. Previous equation in the presence of acid and this equation in the presence of base. So CH3COONA, sodium ethanoate. Is it right? Sodium ethanoate plus water plus carbon dioxide. Same reaction we will get by replacing this sodium carbonate with what? Sodium hydrogen carbonate. Okay, same reaction. Yeah, please note down these two reactions. Sodium ethanoate. Is it right? So this is very, very important. Okay. CH3COONA plus H2O plus CO2. Which gas is liberating here? Carbon dioxide. Okay. So these topics are very, very important. Ester plus alkali.
Once, can you show the reaction?
1 minute, please, dear. Yeah, both are simple reactions only. Acid plus carbonate, acid plus hydrogen carbonate. Which acid here? Which acid here?
Ethanoic acid.
Ethanoic acid. Is it right? Now, yeah, please take the screenshot, dear, or you can watch later as well. Now, ester. What is the chemical formula of ester? What is the chemical formula of ester, dear?
CH3COO CH2CH3.
CH3COO CH2CH3. Very good. And alkali. What is the meaning of the word alkali?
Base
Alkali.
can be
Yeah.
soluble in water.
Bases which can dissolve in water are known as, or which can soluble in water are known as alkali. So here you can see the reaction takes place in two steps: hydrolysis of ester and reaction of acid with alkali. Hydrolysis means adding hydrogen or removing hydrogen. Now here you can see ester plus alkali gives rise alcohol plus sodium salt of carboxylic acid. Okay, hydrolysis of ester. Here CH3COO C2H5 means H2CH3 you will get. Okay, this is also known as CH3COO CH2CH3. This is nothing but C2H5. Both are same. Okay, ethyl acetate, that is ester, in the presence of NaOH. The water present in NaOH is used for the hydrolysis of ester. So here the amount of water which is present in this base solution is used for this process, hydrolysis process. Then the H plus ions and OH minus ions is added to the ester. It gives ethanol plus sodium acetate. It means we will call it as a reverse process. Alcohol plus ethanoic acid gives rise this one, and if you heat this one, then we'll get this one. This is reverse process. Okay, so let me stop you the class here for today. We'll see what is present here. Reaction with alkali. Sulfonification reaction. This is what sulfonification reaction. Ester plus NaOH gives rise CH3COO Na plus CH3CH2OH alcohol. Okay, sodium acetate plus ethanol, that is alcohol. Very easy. Vegetable oil plus NaOH gives rise vegetable ghee. Is it right? Soap solution and glycerol. Soap solution chemical formula C17H35COONA or C15H31COONA. Okay, so let me stop the class here for today.